Chem Kid! Kill!
Hey everybody, Rachel Toby here from Chem Kid 2. So today we are going to be doing experiment 2.2 from Apologia Chemistry. It's on page 58 and we're going to follow it step by step. I'm not going to film every step of it, but I will do every step and explain it if I don't film it. And this experiment is finding the specific heat of a calorimeter. And I know it is a calorimetry problem, and calorimetry problems are really scary because they have lots of numbers. But after this video, they won't be scary anymore because I'm going to explain it and it's going to be fun. So I hope you enjoy. Bye! Okay, so I forgot to mention one thing before I did the experiment. Safety goggles. I know they look really dorky and no one likes wearing them, but you have to because I wear them. And you have to also because they are for your own safety. And I don't want you to get hurt doing chemistry because that wouldn't be fun. So wear your safety goggles. That's it. Bye! So this is our random piece of metal we are going to use for the experiment. So the first thing we're going to do is we are going to weigh it. So we're going to put it on the scale. Okay, so looking at the scale, I'm going to say that this piece of metal is 129.0 grams, because we're measuring it on the gram side, and we have to go to the first place after the decimal point to get our sig figs right. So 129.0. Okay, so now we're going to take our random piece of metal and put it in boiling water. So we put this water on the stove and let it boil, and we're going to leave it in there for 5 minutes, and this will take the temperature of the metal from room temperature, which is 25 degrees Celsius, to 100 degrees Celsius, which is the temperature of the boiling water. Okay, so we filled our calorimeter 3/4 full with water, so we have to measure the mass again so we know the mass of the water that we put in there. And so if you zoom in on the scale, it looks like 209.0. So we've had our thermometer in the water for about 5 minutes now, and we've been tracking it to make sure it's done rising, and we just read it, and the temperature is 27.2. So that's the temperature for the calorimeter, the water, and the piece of metal that's in there. So now we're gonna go into the other room and we're gonna work on math. Okay, so now that we have the calorimeter out of the way, we can move on to metal and water. So you'll see that in the metal and in the water, I have C, M, delta T, and Q. So the C represents the specific heat, which we are trying to find. M represents the mass, which is found in grams. Delta T is, we have the formula for it right here. Temperature initial minus temperature final. So I've taken that in the metal. So our temperature initial was 100 C, which is degrees Celsius. Temperature final was 27.2 degrees Celsius, which gives us a delta temperature of negative 72.8. And that's using sig figs. Everything, all the math I do in my experiment, I use sig figs. We also have the delta temperature down here, which is temperature initial was 23.7 degrees Celsius, temperature final was 27.2, and the final temperature was the final delta temperature was 3.5 degrees Celsius. So up here you'll see that I have an arrow next to C and Q because we are looking for those. Q is the energy lost or gained by the metal. And in water, we have the C, or the specific heat, as 4.184 joules. That is a constant number. It is always the same. So that was given. And then we're looking for the energy that was lost or gained by the water. So I'm going to do a little bit more math here on my paper and then come back and explain some more. Okay, so I copied our information for water over to another sheet of paper. So we were looking for the Q of water, which is right here. And so we use this formula right here. Q equals M times C times delta T. And so we plugged all these numbers into the formula. So it was Q equals 4.184 times 193.3 times 3.5, and we ended up with 2,800, and that is how much our Q is. And I didn't write this on the paper, but the measurement for that is joules, which is the J, over grams times degrees Celsius. So it would be J over G times degrees Celsius. Now we are going to move on to metal and find the Q, or the energy lost or gained, for metal. Okay, so this is the formula we use to find the Q of the object, and the object is the metal. It's negative Q of object equals the Q of water. So as you'll see on the second line right here, the Q of water was 2,800, which is what we just figured out. And so then if you just take the negative sign over to the right side of the equation, we find out that the Q of the object equals negative 2,800. And so I put that right here in the metal. So the Q of the metal is negative 2,800. And so now, as you can see, the only thing that we're missing is the specific heat of the metal, which is what we were trying to find in this experiment. So now we will use the formula Q equals M times C times delta T to find the specific heat of the metal. Okay, so I copied everything we have about the metal onto this sheet. So we're using the formula that I talked about in the last clip. Q equals M times C times delta T. So we filled in that formula with all the information we have from over here. So Q equaled negative 2,800 equals M, which was 129.0 grams, times C, which we don't know yet because that's what we're looking for, the specific heat of a metal, times delta T, which, as we can see from over here, was negative 72.8. So if we go down to the next level, on the left side it stayed at 2,800, and then I multiplied together the 129.0 grams and the 72.8, and we got negative 9,390. And then we still have C, because that's what we're looking for. So if you divide both sides by 9,390, you get C all by itself on the right side, which is what we want to do, because we're looking for C, or the specific heat of the metal. So if you divide both sides by 9,390, on the left side the negatives cancel out and you get 0.30 with your sig figs. And then on the right side, the 9,390 cancel out, and you're just left with C. So that leaves us with our answer. So the specific heat of the metal equals 0.30 joules. So that's what we've been looking for. So here's the final answer. So as you can see, our whole sheet is filled out now. We have the calorimeter, which we didn't use at all because it didn't affect the problem. We have the metal, and we have the water, and everything with the arrows by it, which was the things we were looking for, and the metal and the water is filled in. And because all those are filled in, we got our final answer of C equals 0.30 joules. So that is the specific heat of a metal. So I hope this video was helpful, and this was my first video on my channel, so hopefully it turns out good. And if you liked this video and if you want to see more, let me know in the comments below and tell me what my next video should be about. So I'll see you guys soon. Bye.